right? So you don't immediately go to the next command. Something that is very difficult for individuals to understand is that if you add examples, it's not helping. Okay? It's not going to help them to get it to say it 3 or 4 different ways. That's going to make it more difficult. So if I want you to get the blue plate out, I'm just going to say, get the blue plate out. I'm not going to say, remember, it's the one on the top shelf. Remember, it's the one you used yesterday. Remember, I think we washed it and put it in the sink holder. No. Succinctly, get the blue plate. Allow time for processing. Now, we've talked about the fact that individuals with autism can have difficulty with complex information. What makes something complex? Well, it can be complex because of the quantity there is. There's lots of small units, like looking at a list of spelling words for the week. The structure and that complex story with a theme or a visual scene. If I say, the night was dark and cloudy and the wind was howling. That's a visual scene that has lots of elements to it that need to be processed. Multiple modes of input that need to be integrated. The information is coming in different ways. Time constraints. If you've got to do something fast, it can be more difficult. Multiple simultaneous processing demands. Things are coming at you in at the same time, not in a different way necessarily, but at the same time. And then if you have stress or anxiety, certainly that goes along with this as a secondary issue, it can be very difficult. So complex information all around us. How autism is different from other disabilities that affect learning. So let's think a bit about this information processing. If we have general intellectual disabilities, this is some perhaps has lower cognitive skills, what we might call mental disabilities or retardation. In this case, both the simple and the complex information processings are impaired. Can't get either well. If we have learning disabilities, only the simple information is impaired. But if you are looking at autism, only that complex information processing is impaired. So what I want you to take away from this is that when you're looking at information processing, complex information is more difficult. Now, there have been great new advances in technology that have really allowed us to literally look inside the brain of people who have autism. Functional magnetic resonance imaging, and you've probably heard that referred to as fMRIs. This looks at the electrical activity occurring in the brain while a person is doing something. So it doesn't just look at a static brain, but it looks at a brain when someone is doing a task, when they are putting together a puzzle, when they're making themselves a sandwich, and they can see what electrical activity is occurring in there. So this has really opened up a lot of research related to autism. If it's the basic architecture of the brain that's different, what is going on in the brain that is different? These fMRI studies have shown some things. During cognitive tasks, the brains of individuals with autism, when you compare them with controls who do not have autism, you find that there's more activity in some areas of the brain, less in others. There are fewer connections and correlations among the different areas of the brain. So there are fewer connections, and with that, less synchrony between the activities in the brain. So different things going on. Going on to a sentence comprehension task. Remember, this fMRI allows you to look at someone's brain activity. This was during a sentence comprehension task. What they found was that there was more activity in the word recognition on the surface of the gray matter, but there was less activity in the area that processes meaning. So there was activity in the word recognition, but not in the meaning of that. And there were fewer connections and correlations among the 10 regions of the brain that participate in what we call language functioning. So the brain looked different, and how it was functioning was different. Similar results suggest that there's an underconnectivity. Right? This goes with the way that the brain is working, parts of the brain are working together. And this underconnectivity have been seen in tasks that involve things like social thinking, how to handle a social situation, problem solving, what am I going to do if this doesn't work, and inhibiting that inappropriate behavior. Remember, we said that individuals with autism may be less able to inhibit inappropriate behavior. If they're feeling it, they do it. We're able to override that and inhibit those inappropriate behaviors. So we have some underconnectivity. What's the effect of that underconnectivity? Well, when demands change and the brain has to come up with new ways of dealing with things, that problem solving, there are fewer connections, and that means less flexibility and fewer resources to draw on. So, if we're made to come up with new ways, our brain is less able to make those connections to understand and execute those new ways. If you look at underconnectivity implications for intervention, what you need to do is focus on really developing the alternative approaches and strategy development. So rather than just simply giving students facts or rote memorizing things, you're going to try to give them approaches for strategy development. What's an alternative way you can do this? How can you arrive at this answer? And I have to say, my children are involved in secondary, are in second grade here in State College, and they're working on a curriculum math that has these alternate approaches and strategy development. And I tell you, I have the worst time with their math assignments and how they come up with multiple ways of solving a math problem. I was taught in the old school of facts and rote memory learning, but it's interesting to see. Mommy is always having to hand back homework that I don't understand, but my 8-year-olds seem to understand and grasp better than me. So focus on alternative approaches. We also know that individuals think in pictures. During those fMRIs, in a working memory task with letters of the alphabet, the fMRI showed that individuals with autism and the control group got similar scores. Okay, so they have working memory tasks with letters, okay, but it showed that the brains in the autism group processed those letters differently. They processed those letters as graphics. Okay, so they saw them as a figure rather than a word. The control group recoded into letter names, so they were able to put an A with a B, but the group with autism put those into graphic pictures or figures. So this gives us an idea of why thinking in pictures occurs. So an example, fMRIs were done while reading two types of sentences. That high imagery, there was a rainbow over a cornfield, so we've got to visually think it. Low imagery, addition and subtraction are mathematical operations, so don't use a lot of imagination there. Visual imagery areas in the brain of individuals with autism activated for both types of sentences. The same areas in the control group only activated during the high imagery sentences. Okay, so we really have a difference in how individuals are processing. What does this tell us in terms of implications? Visual strategies are very useful for persons with autism. We're going to get into that quite a bit more when we look at structured teaching. But use visual strategies to communicate information. There's a wonderful book by Temple Grandin, a woman who has autism, and she has titled the book Thinking in Pictures, and it tells about how she sees information and makes sense of it in her mind to process the information, and it's done visually by thinking in pictures. But there's always a caveat here. Not all individuals with autism are visual thinkers. Predominantly, yes, but some think in words. So we're going back to that very heterogeneous grouping of students. They're very, very different. Most are visual thinkers, but you can't say all. If we're looking at memory abilities, and we're still looking at those fMRI studies, the basic memory abilities are intact with this population, but capacity to learn and remember lessons when that information becomes more complex. So as we get more elements to it, it's more difficult to put it in our memory. And this happens for both visual and auditory information. What can you do to improve that learning and memory? Well, present the material in small chunks, not large strings of information. Start with the first step, stop and wait for a response, move to the second. Start with that big picture rather than the examples. So start by saying, today what we're going to do is make a collage. Don't go into the examples of it, the big picture. Provide extra time for people to think. And keep materials for rehearsal at the individual's own pace. It may take them more time to rehearse and get the information. Okay, giving you an activity for reflection. Again, something for you to think about. Given the difficulties with memory and learning of complex tasks, I want you to outline how you'd approach teaching an elementary student about a topic of environmental conservation. So knowing how memory and learning are different and how they're different with complex tasks, how would you begin the lesson differently? Give you a hint, starting with that big picture. What assignments would be useful? How would you tell that student the directions for the assignment? And how would you be sure he or she understood the lesson? Think about that in terms of the research we have just discussed. Brain basis for ASD. Individuals with severe autism have more severe neural underconnectivity. So underconnectivity is an issue, but when that autism is more severe, the underconnectivity shows up to be more severe. Information processing capacity is progressively truncated as the disability progresses. So, in more severe cases of autism, the brain attaches almost no meaning to sensory input. We're not attaching meaning to what is happening. The implications for this brain basis: students with autism will not demonstrate the same level of common sense or problem-solving ability as neurotypical kids with that same IQ. This is so annoying. Common sense. I don't know how many times you say to a child, use your common sense. You know it was not a good idea to do that. But with this brain basis implication, students with autism are not going to have that same level of common sense. And we know that their social behaviors are going to lag behind their academic abilities because of what we know about the brain's architecture. Students with autism may not have executive functioning. Those are those decision-making processes. The higher order to override initial tendency to resist doing hard or unpleasant things. They're just going to say no. I was in a classroom recently, and the teacher constantly asked this girl with autism whether do you want to start your homework now? Are we ready to get going for lunch? And every time the student answered, no, I don't think I do. No, I don't think I am ready. She's just telling her tendency to resist doing what she didn't do. She was given